Every single day, India's economy is kept alive by a continuous, rolling conveyor belt of millions of heavy cargo trucks. Keeping those machines moving requires a massive, constant distribution of fuel across thousands of stations nationwide. But if you look past the headlines about petrol, the data reveals a different reality. This chart compares India's annual fuel consumption, and it shows the country burns through almost twice as much diesel as it does petrol. That diesel powers the true backbone of the nation, the heavy commercial trucks, public buses, and agricultural equipment that move India's cargo and food. For years, the green fuel strategy has focused on blending 20% ethanol into petrol for passenger cars. But that same ethanol cannot be used in a diesel engine without causing catastrophic failure. Ethanol is an alcohol that naturally attracts water. In a diesel tank, it separates from the fuel, forms droplets, and initiates rapid corrosion on internal metal surfaces. It also lacks the energy density required to move a heavy load. This creates a wall for the energy transition. Replacing millions of expensive truck engines is an economic impossibility, so if we want to decarbonize freight, we have to change the fuel itself. To solve this, the government is preparing a policy pivot specifically designed for the needs of heavy transport. Road Transport Minister Nitin Gadkari recently revealed the next phase of this strategy. The proposal is to permit a 15% blend of a different biofuel, isobutanol, into the national diesel supply. This chemical integration allows India's massive existing fleet of heavy vehicles to operate under strict modern emission standards without the need for total mechanical replacement. Isobutanol is a biofuel, but it isn't made from standard fermentation. It requires processing specialized agricultural waste, like the fibrous residue left after crushing sugarcane. It can also be produced from alternative high-yield crops like bamboo, which grows rapidly on marginal land without competing with the food supply. The advantage of isobutanol is hidden in its molecular structure. Ethanol is a simple C2 alcohol with only 2 carbon atoms. Isobutanol is a more complex C4 alcohol with a longer, heavier carbon chain. This structure is the key to energy. A longer carbon chain carries more energy, allowing isobutanol to provide a power output that matches standard diesel. This makes isobutanol a high-performance biofuel, chemically equipped to survive the high-pressure environment of a commercial engine. We can see the results of this chemistry in recent engine trials published by the Indian Journal of Scientific Research and the IJRET. These tests use specialized rigs to measure exactly how biodiesel blends perform under load. One primary finding is perfect miscibility. Unlike ethanol, isobutanol blends smoothly with diesel and stays stable without separating or absorbing moisture in the fuel lines. This graph illustrates the thermodynamic impact. As the percentage of isobutanol in the blend increases, the recorded exhaust gas temperature during the combustion stroke drops. Lowering that peak temperature reduces the formation of nitrogen oxides, or NOx, one of the most difficult pollutants to control in diesel engines. This cleaner combustion also results in a significant reduction in the black soot and smoke typically emitted from heavy transport tailpipes. This 15% blend allows existing engines to align with the strict limits of BS6 emission norms without requiring expensive mechanical retrofits. On a national scale, replacing 15% of diesel consumption with a domestic alternative directly reduces the billions of dollars India spends annually on foreign crude oil imports. To reach this target, India is building high-capacity facilities to process agricultural residues into fuel at an industrial scale. Domestic engineering firms like Praj Industries and Raj Process are already designing and building the specialized plants required to produce isobutanol. This solution scales from long-haul freight trucks to the urban transit networks that move millions of people through our cities every day. The mandate functions as an industrial catalyst, turning an environmental requirement into a new domestic energy sector. This transition allows millions of heavy vehicles to lower their emission profiles using the exact engines they already have. While electric vehicles are expanding in the passenger sector, batteries cannot yet provide the sustained torque needed to move heavy freight across the country. This policy extends the decarbonization benefits seen in passenger cars to the heavy commercial lifelines that drive the country. Ultimately, India's energy security won't just depend on imported minerals. It will be built on advanced alcohols harvested from our own agricultural fields.